If you are active, indicate that you are active. Good evening, guys. Please, if you are active, indicate in the comment section that you are active. Please, if you are active, indicate that you are active. Once you just come online, please indicate that you are active. Indicate that you are active. Indicate that you are active. Please indicate that you are active. Please indicate that you are active. If you are active, indicate your presence. Indicate that you are active. If you are active, indicate your presence, that you are active session. All right, Chidima, Veronica, you are welcome. Please, others should indicate in the comment section. Please indicate that you are active. If you can hear me clear, please indicate that you are active. Indicate that you are active. Please indicate. We are starting the class now. Please, if once you join, please share the link to other of your classmates. Let them join as well. Please share the link to them. Let them join as well. Please share the link. Let's share. Let's keep on sharing. Let's share the link to others to join. Let's share the link to others to join. Okay, we have 2 persons now. Please, once you join, click on the like button so that we can go viral. Please click on the like button for more visibility. The more we click on the like button, the more we have more visibility. Please just click on the like button. 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 All right, so we are starting. Okay. We are still on integration. Yesterday, we talked about integration as the reverse process of differentiation, and we looked at some of the various forms of integration, right? And we say that integration is generally represented by a symbol called integral. That integration is represented by a symbol called integral. Integration is a reverse process of differentiation. Then yesterday we talked about the integration of a change in a variable. We talked about integration of power rule. We talked about integration of inverse linear function and integration of function of a function of a linear function. All right, I will just do a little recap, then we proceed. This class is a continuation of yesterday's class. So please, if you missed yesterday's class, make sure you go through the video, through yesterday's class, and update yourself, because I'm not going to repeat myself here. I will continue. Okay, then after today, we meet again, possibly tomorrow or Monday, for other aspects of integration. And I'll be welcoming questions from you guys. So if you have any question, you can always ask in the comment section. Please, if you have any question, you can ask. Once you join, click on the like button and share the link to others. Please share the link to others. Okay, yesterday we said that integration is a reverse process of differentiation. Integration is a reverse process of differentiation. It is also called anti-differentiation. Right? Anti-differentiation. That's called integration, anti-differentiation. And the symbol for differentiation of integration is integral, right? And we started by saying that if we are given y equals to a function of x, and we have to find the y dx equals to f prime of x. So here we have our dy equals to f prime of x times dx. By the time we cross multiply this expression, that will give us this. Then to find y, we have to integrate both sides, meaning integral of dy equals to integral of f prime of x dot dx. Okay, the integral of a change in a variable integral in the change of variable equals to the variable, meaning integral of the y equals to y, integral of the x equals to x plus c, integral of the w equals to w plus c. So if I'm to integrate both sides, this simply means y equals integral of f prime of x dx, which is equals to f of x plus what? Plus c. F of x plus c. So whenever we integrate a function, we always add c to the function. We always add c to the function because differentiation eliminates constants. When you differentiate an expression, okay, that has a constant, the constant will be eliminated. So anytime you integrate a function with respect to change in that function, we have to add what? C to it. C means constant. And the reason why we have to add C is because in differentiation, constant is being eliminated. All right? So the first rule we talked about is that integration of a change in a variable is equals to the variable itself. Then we talked about integration of change in a variable equals to the variable, meaning integral of the y equals to y plus c. Okay, integral of the x equals to s plus c, integral of the h equals to h plus c. Then we also talk about integration of inverse linear function. Inverse linear function, meaning if I have an expression, I have integral of 1 over as plus b, all in the x, and we have to integrate this. The result becomes 1 over a ln as plus c, as plus b, as plus b plus c. This is what we discussed yesterday. Like I said, I'm not going to repeat any. All right, we'll just proceed. But while solving, I might likely touch one or two while solving. Then we also talk about the integration, this integration of inverse linear function. Then also have integration of function of a linear variable. Meaning if I have an integral of as plus b to the power of n. We talked about this as well and all that. Now, in today's class, we shall be talking about other forms of integration. Other forms of integration. But before we go into other forms of integration, I came across a past question. That was last year past question. Last year past question, which is 2023/2024. Past question. Question number 4. Question number 4, I guess. Question 4. This is for Imo State University students, IMSU students. We have to evaluate the first question, integral of 2x to the power of 3 minus 3s divided by 4x dot dx. All right. Number 2, integral of 4 divided by 5x plus 3. 5x plus 3 times dx. Solution. Let's solve the first one. This is IMSU past question. IMSU past question. If you look at this, we have 2 terms there in the numerator, then we have a term in the denominator. I can divide each of these with 4x, meaning 2s cubed divided by 4x minus 3s divided by what? 4x. That means this expression here, integral of 2s cubed minus 3x divided by 4x can also be expressed as 2x cubed divided by 4x minus 3x divided by what? 4x. Please don't forget there's a dx here. We have a dx dot dx, okay? All times what? Dx. All times dx. So by the time we evaluate further, this will give us integral of s. One of these x here, we cancel this x, right? Yeah, we're going to have here as 2 also cancel itself. 2 here is 2, 2 here is 1. So we have s cubed, s squared divided by 2 minus s can cancel s here. Yeah, we'll be left with 3 over 4. All in what? All in dx. All in dx. Then I will use the integration of sum and difference. The principle of sum and difference. Meaning I will integrate this, also integrate this separately. Don't forget that anytime we are integrating a constant, let's say k dx. Well, we are integrating a constant k dx. The expression will give us what? Ks plus what? Plus c. So for example, if I'm to integrate 3 dx, the answer becomes 3s plus c. Are we there? What I'm saying, because I have a constant here. After dividing, cancelling out this x, we generated a constant, right? So integral of 3 over 4 dx will give us 3x over 4 plus what? C. So that means whenever we differentiate this, the result will be 3s over 4. All right? Okay, don't forget this expression. We learned this yesterday. I gave us an integration of a change in a variable is equals to what? To that variable, right? Plus c equals to the variable itself plus c. So, but if we have this alone, let's say there's no k here, what will be here is s plus c. But because we have k, I have to factor out this k, right? Then when we integrate the s, the result is what? S plus c. Let me repeat this again for clarity. Integral of this, integral of k dx will give us k integral of the x. And I say that integration of a change in a variable, the variable here is x, is equal to the variable itself plus c. So that means here will give us k times integral of the s is x plus c. So that means our integral of k dx becomes what? K times s is kx plus c. The same thing we have here. So anytime we have an integral of a constant multiply with a change in a variable, just multiply that constant by that variable, then plus c. That is the principle of integration. So for this, I will integrate them individually, right? This will be integral I equals integral of x squared over 2. Okay, this is the same as 1 over 2 s squared. 1 over 2 s squared. Or I can say s squared over 2 or half times s squared minus integral of 3 over 4 all in what? Somebody? All in the x. All in the x. So that means here becomes our I equals half times. By the time I will bring out this half here. Here becomes 1 over 2 integral of s squared dot dx. Okay. You know, we are multiplying ds with the whole of this. Here will be s squared over 2 ds minus 3 over 4 ds. Okay. So here I will have put my dx, but because of space, so just take note. That's why I have to put all of them in what? In the x. So I'm expanding this now. It means that here becomes half s squared dx minus 3 over 4 integral of dx. Right? So here becomes our I equals to half times integrating x, the s will give us x to the power of 3 divided by 3 minus 3 over 4. Integrating the x, 1 dx will give us what? X. Is that not? The rule says anytime we integrate a change in a variable, is always equals to that variable. But don't forget the rule of integration. After integrating, I have to add my constant was c to it. So that means here becomes our I equals 1 times s cubed will give us s cubed, divided by 2 times 3 is 6, minus 3 over 4 x plus what? Plus c. This is the final answer for the first question. This is IMSU pass question, and this is what you expected to have at the end of the day. Now let's see the second question. Please take note of this. Please, if you have joined this live class, make sure you click on the like button and make sure you share the link to your course mates. Please, let's share the link. Please share the link, 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 please. I want you guys to, I need more comments. Please comment if you are following. Okay, Chidima, you are welcome. Victor, you are welcome. All right, you're welcome. You're welcome. You're welcome. You're welcome. Happy new month, Victor. Okay, so please let's share, let's share, let's share. Keep on sharing. Share it to your course mates, your departmental group. Please share it now. Share it now. Share it now. All right. So let's look at the second exam question. Second question. IMSU exam, just last year. Very simple question. And all of this we learned yesterday. Look at this. Number 2. Question 2 says, integrate 4 divided by 5x minus 3 dot dx. 5x minus 3 dot dx. Let's look at this question together. We mentioned a law, a rule of integration called the integration of inverse linear function, meaning integration of 1 over as plus b dot dx will give us 1 over a ln as plus b ln ax plus b plus what? C. We mentioned this yesterday, that anytime we have 1 over, and this is an inverse function, right? The result becomes 1 over a ln as plus b plus c. Then that means that if I have something like 2 divided by as plus b dot dx, it means I have to factor out these 2, then bring out the inverse linear function, which is 1 over ax plus b dot what? Dx. Because the general rule says that integral of an inverse linear function is equals to 1 over a ln that function as plus b plus c. So giving us this, I will have to factor out 2, and that will give us what here? 2. Integral of this becomes what? 2 ln as plus b plus what? Plus c. This should be the final answer to this. So for this, it means I have to factor out 4, right? By the time we factor out 4, this becomes 4 integral of 1 over 5x minus 3. The final answer becomes I equals 4 ln. Okay, let's move this. Okay, sorry, we made a mistake here. This will have been 2 over a, because we say that 1 over as plus b is 1 over a ln as plus b, right? So if I have 2 over as plus b will be 2 over a, right? 2 over 2 integral of 1 over what? As plus b. Then this will now be 2 over a, because already the integral of this is 1 over a ln. Here become 2 over a ln as plus b. Sorry, I just made a correction now. Please take note of this. Take note of this. If I have this integral of 1 over as plus b ds is equals to 1 over a ln as plus c. So for this, I will factor out these 2. Here becomes 2 integral of 1 over as plus b dx. then the final result becomes 2 times 1 over a, which is 2 over a ln as plus c. So that means this will be 4 over 5 ln 5x minus 3, then plus what? Plus c. But let's verify. But this is not how you expected to solve this in the exam. How should we solve this in the exam? Take notes. We are given this. The question says integrate, evaluate 4 divided by 5x minus 3 dot what? The x. Let's verify if this is true. So here we have solution. We're going to say let u equals to the denominator. U will give us what here? 5x minus 3. 5x minus 3. Let's call this equation 1. Are we there? Then I will differentiate u with respect to x, meaning the u over the x will give us 5. The u over the x will give us 5. Here I will apply differentiation here. Okay? Why are we doing this? If I'm saying that let u equals to 5x minus 3, here become 4 over what? U dot what? The x. So I'm going to look for a means to substitute to eliminate this dx. Now, for me to eliminate the x, I have to bring in the right to integrate what? 4 over what? U. And the right to integrate 4 over u is actually du. So what we have to do here, we have to say let u equals to 5x minus 3. And that will give us this equation 1. Then I will differentiate this. In this case, we are introducing differentiation, meaning du over dx. The result is 5. Now, what do we do now is that I will now look for a means to generate my ds by making my ds as what? As subject of the formula. Now, let's watch. I will cross multiply this. This will give us du times 1 is du. Du is equals to 5 dx. We just cross multiply. Then that gave us du equals to 5 dx. Now, our aim is to make the s as the subject of the formula. So what do? We divide both sides by what? By 5. I divide both sides by 5, both sides by 5. When we divide both sides, this can go right. That implies that my dx is equals to du over what? Over 5. Let's call this equation what? 2. Therefore, integral of 4 over 5x minus 3 dot dx becomes integral of 4 over 5x minus 3 is what? Is u, right? Here becomes over u dot du over 5. Our ds, this is ds, this is me, this is dot dx. And we have already solved for dx here. The s here is actually du over 5. Here becomes du over what? Over 5. Du over 5. So by the time we evaluate further, this becomes 4 over 5 du over u. So here becomes our I equals to 4 over 5 integral of du over what? U. This is also same as 4 over 5 integral of 1 over u dot what? Du. And yesterday we mentioned that anytime we integrate 1 over u will be what? Ln u. Integral of 1 over u is ln u. So that means our I equals 4 over 5 ln u plus what? Plus c. So I becomes what? 4 over 5 ln. Our u is 5x minus 3. Don't forget. Then plus what? Plus c. Now you see why we say that the former expression we generated is actually correct. It's much more correct. Okay. All right, so let's Continue. So what we are saying is that, don't forget that, recall, integral of a linear inverse function like 1 over as plus b is equals to 1 over a ln as plus b plus c. So let's say if I have an integral of c over as plus b dot dx, all right, this is dot dx, don't forget, dot dx, that will give us what here? Since this is 1 over a, and here we have c here, c represents a constant, here becomes c over what? A ln as plus what? Plus b, then plus c. So for this question here, our c is actually 4. So that means here will be to integrate this 4 over 5x minus 3 dx. That will give us 4 over, our a here is 5, 4 over 5. Then I'll bring out what my ln as plus b, which is 5x minus 3. 5x minus 3, then plus what? C. This is the shortcut method. But for IMSU exam, don't use the shortcut method. You have to solve by making this your u. Then when you make this your u, then get your dx. Are you there? Then substitute your dx. After then you can solve further, just like we did here. Are we there? Now let's look at, this is just the past question. Now let's go. Let's move. Let's continue from where we stopped yesterday. Please, if you are following, indicate in the comment section. If you are following, indicate in the comment section. Okay, let's look at integration on this form. Integration of the form integral of g of x f of g of x dot g prime of x f of g of s. Okay, we also call this integral of f dot fu dot du, or fu du rather, fu du. All right, another name for this form is called the U method. It's called the U method. U method under direct substitution. Under direct what? Substitution. This is called what? The U method. The U method under direct substitution. Now let's see some questions. Let's solve some question. Question 1. Under this. Question 1. Question 1 says evaluate integral of x dot s squared plus 1 to the power of 5 dx. Integral of. All right. Now let's look at this form of integration. Integration of the form integral of f g of x dot g prime of x equals to fu du. G of s is same as u, while g prime of s is same as du, right? Okay. So that means that this g prime of s means the derivative of what? Of g of x. Whenever we see prime talks about derivative, the first derivative function. All right, so we have to evaluate this. So what do we do here? We have to use what we call the U method or direct what? Substitution. Now listen, we have to look for a means to solve this by using the U method. Solution to this, I'm going to introduce some concepts here. In this form, the most important thing we need is the U and what? And the U. If you can be able to identify your U and the U, you can be able to solve the expression. Then I have two functions here. I have x and I have x squared plus 1 to the power of 5. I'm going to make this to be my U. I'll make this to be my U, the one that has a power, the co-function, to be my U. By the time we make this to be U, I'll say let U equals to what? S squared plus 1. Let's call this equation what? 1. If U equals to S squared plus 1, I will differentiate this. By the time we differentiate this, this will give us the U over what? The x equals to 2x. Don't forget. So here, I will cross multiply. That will give us the U equals to 2x dx. The reason why we are differentiating is to generate a variable that can cancel out this x, because I don't need this x in this integration. All we are looking for is a means of expressing the whole of this to be in this form, U du. Now, the first we have to do is to find what first? U. Make this your U. When you make this U, then what we do next is to find what the U. When you're able to find your U and get your du, then you can be able to integrate. So the challenge is always, which of these functions will I make U, and which will I make what? Du. If you make this your U and you differentiate this, the result will be 1. And 1 cannot cancel any of this term here. But by the time we make this co-function my U and differentiate, that will give us what? 2x. X in 2x, we cancel this x from here. Let's watch and see. Now we have seen that our du is what? 2x what? The x. The next thing we need to do is to make the s a subject of the formula. Here becomes our dx equals to what? Du over what? Over 2x. Let's call this equation what? Equation 2. Okay. Therefore, integral I equals to x dot s squared plus 1 to the power of 5 dot dx will become I equals to integral of, we have x dot, we represent this as u, right? Here becomes dot u to the power of 5 times our dx is du over 2x. Here becomes du over what? 2x. Don't forget, we have our x, which is this. We have already said let u equals to this, which is u to the power of 5. Then the s, we make the s a subject, which is what we have here as du over 2x, right? Then what you notice here is that this x here, we go with this x. If they should cancel out, then our integral I becomes integral of u to the power of 5, right? Dot du over what? 2. This is same as 1 over 2 integral of u to the power of 5 dot what? Du. So what do we do here? What do we do here? We have to factor out 1 over 2 as the constant. Then we have to bring out the constant. Like I explained to us that anytime we have integral of k, the x, it becomes what? K integral of what? The x. So whenever we have a constant, we have to bring out the constant. Then we can then integrate. So that means that here becomes, our integral becomes 1 over 2 times, I'm going to use the power rule of integration here. The power rule says I will add 1 to this power and divide by the resulting power, meaning half times, let's integrate this. Yeah, this will give us u. By the time we add 1 to 5, that will give us 6. Divided by what here? 6. Then plus what? Plus c. 1 over 2 times u over 6 will give us, I hope I can clear here now. This will give us I equals to 1 times u to the power of 6 is u to the power of 6. 2 times 6 is 12. Then we have plus c. But don't forget, we say that let u equals to s squared plus 1. That means our integral becomes s squared plus 1 all to the power of 6 divided by 12 plus what? Plus c. This is the final answer here for this question. Divided by 12 plus what? Plus c. This is the final answer. Next question. Next question. Question 2. There's another stuff. Let me show us something, guys. I would like to show us something. Still in that same question we just solved here. This same question that says integral of s dot s squared plus 1 to the power of 5 dot dx. I have another method I would love to show us. Then let's compare which of the method we prefer. Listen, guys. You know we say let u, right? Let u equals to what? S squared plus 1, right? Then here we have our du. Our du becomes 2x dot dx. Don't forget. Du dx. When you differentiate this du over what? Dx, that will give us what here? 2x. Then by the time we cross multiply, du times 1 is what is du. Equals to what? 2x times the x is what? 2x dx. So that means du equals to 2s dx, right? Now listen. So this means integral of x dot s squared plus 1 to the power of 5 dx equals to integral of, let's check out something here. Look at this. Look at this. I have here as, okay, let me take off this first. I have here as s dx. S times s squared plus 1 to the power of 5 dot dx. This, and this are products. So this is more like saying x dx. And here we have x dx here. So what we do here, I can make my s ds a subject of the formula, meaning I'll look for a means to eliminate these two from here by dividing both sides by 2, Abi, by 2. These two, we cancel these two here. Then we have du over 2 is equals to what? X what? Dx. What does that mean? Anywhere we see s ds, I will put what? Du over what? 2. Then anywhere we see u, I'll put what? S squared plus 1. Are you there? You can decide you want to use. If the first example is okay, you can go with that. But if this is complex for you, you can leave it. But if this is okay, you can also go with this. What I'm just saying here is that after letting u equals to this, differentiate, we have du. Du equals to 2s dx, right? Then for us to find our sds, because we have sds, it means I will divide both sides by 2. And that will give us du over 2 equals to what? Sds. I hope this is clear. So that means that this expression you are seeing here, integral, okay, of x dot s squared plus 1 to the power of 5 dx becomes integral of s dx. Already we said is what? Du, right? Du over what? 2. I've already represent my sds as this. That means it's remaining this, right? And this expression, we use what? U to represent it. So times U. U to the power of what? 5. So this will give us what? 1 over 2 integral of U to the power of 5 dot what? Du. And that will give us 1 over 2 times U to the power of 6. To the power of 6 over 6 plus what? C. Here we have 1 over 12 dot U to the power of 6 plus C. And that will give us what here? Okay, here we have, okay, let's just say U to the power of 6 over what? 12, right? Plus what? Plus C. And that will give us what? Our U is actually S squared plus 1 divided by what? 12, all to the power of 6, then plus C. Any of the method you are okay with can also go. All right? So this is just it, yeah? Let's see another example. Integration. Please, if you are following, indicate in the comment section. If you are following, indicate in the comment section. Okay, question number 2 says integrate 7s dot 3s squared minus 7 dx to the power of 19. To the power of 19. Okay, the same thing we're going to do here. I'm going to say let U equals to the cofunction 3s squared minus 7. That means that the U equals to 6x dx. Am I communicating? 6x dx. Well, let me show all workings. I will differentiate U, right, with respect to x, meaning du dx equals to what? 6x. Then I'm going to cross multiply this. This will give us du equals to what here? 6x dot what? Dx. Is that clear? Good. Now, let's make our ds a subject of the formula. It means I will divide both sides by what? By 6x. By what? By 6x. So 6x can go with this. So we have our dx equals to what? Du over what? 6x. Let's call this equation 1. Let's call this equation what? 2. Okay. So that means that integral of 7x dot 3s squared minus 7 to the power of 19 dx will be equals to integral of 7x dot our 3s squared minus 7 is what? Is u. So we have u to the power of 19 times our dx is du over 6x. Is du over what? 6x. Right? So what we notice here is that s can go with this x from here. I have to cancel that x because I don't need x in the integration. So here we have our I equals to integral of, we are left with 7, okay, 7u to the power of 19 dots du over what? 6. This is same as 7 over 6, right? 7 over 6 integral of what will remain here will be u to the power of 19 dot du. So our I becomes what here? 7 over 6. Integrating u to the power of 19 will give us u to the power of 20 over what? 20, right? Then plus c. For those of you who just joined us, in integration, the power rule of integration states that integral of x to the power of n dot dx is equals to x to the power of n plus 1 divided by n plus 1, then plus c. This is called the power rule of integration, meaning I will add 1 to the power and divide by the resulting power. That is exactly what happened here. So I added 1 to 19, then divided by what? By that resulting power, okay? Then plus c. So this will give us integral of 7u to the power of 20 divided by 6 times 20 should be about 120, right? About 120. Then we have u to the power, sorry, plus what? Plus c. Plus c. Please, if you are following, indicate in the comment section. Indicate in the comment section. So what we do next is that we have to put the value of u. Then our integral I becomes 7. Our u is 3x squared minus 7. The power there is 20. All divided by what? 120. Then plus what? C. Final answer. Final answer. Okay. Next question. Next question. Still on that form of integration. Still on the form we are discussing on. Still on the form we are discussing on. We are asked to evaluate integral of sine x dot cos x dot dx. Sorry. Okay. Now let's look at this. I want us to recall something here. In differentiation table, we say that if we have y and we have y prime or dy dx, if we differentiate sine x, we're going to have cos x. If we differentiate cos x, we're going to have minus sine x. If we differentiate exponential x, we have exponential x. If we differentiate exponential kx, we're going to have k exponential what? Kx. If we differentiate tan x, we're going to have sec square x. If we differentiate ln x, we're going to have 1 over what? 1 over x. So, the same thing also occurs here. When you integrate cos x, we have what? Sin x. If integration is the reverse process of differentiation, that means anytime we integrate cos x, we have sine. If we integrate sine, we have minus cos. If we integrate exponential x, we have exponential x. If we integrate k exponential ks, we have what? Exponential what? Ks. If we integrate sec square s, we have what? Tan x. If we integrate 1 over x, we have what? Ln x. So for this, I have to say let u equals to sin x equals to sin x. Why did I say u equals sin x? Because for me to find my du, I have to differentiate u, right? By the time we differentiate u, that will give us what? Cos x. Don't forget that we are looking for a form. We want to convert this to this form. The form that says, well, u dot what? Du. I have to make u to represent a function. Then anytime we make u, when you differentiate u, you should have what? Du. Are you there, somebody? So what we do here is to make u equals to sin s. If you make u equals to what? Cos x. By the time we differentiate u, du dx, I will have what? Minus sin x. Is that not? Minus sin x. And in this expression, we don't have minus sin x. So I can't make u cos x. I can only make u what? Sin x. All right. So if u is equals to sin x, so that means our du dx will give us what? Yeah? Cos x. So from here, our du equals to what? Cos x dot what? Dx. Cos x dx is du. Sine x is u. That means we have been able to convert this to what form? To the form of integral for u dot what? Du. Or I can also come from here and say, let's make the x as well subject. Make the x subject of the formula. That will give us the x equals to what? Du over what? Cos x. Okay, so let's see. Please take note of this. So this will give us our dx. This is equation 1. This is equation what? 2. All right, so we make our dx as subject by dividing both sides by what? By cos x. So that means our integral of sine x dot cos x dot dx will be I equals to integral. Our sine x is already u. Okay, let's move again. Our cos x. We already have our cos x. Right? Our cos x. All right? We already have our cos x. Then we have our dx as what? Our dx is du over what? Over cos x. Don't forget. Our sine x is u. Our cos x remains. The s is what? Du over cos x. So this can go with this. So our integral becomes integral of u dot what? Du. So here we apply the power rule of integration. The power here is 1. This becomes I equals to what? U squared divided by, okay, let's apply it. We have u 1 plus 1 over 1 plus 1, then plus what? C. And this will give us integral I equals u to the power of 2 divided by 2 plus what? C. Then I becomes what here? Our u is sine x, so we have sine x all squared over 2 plus c. This is the same as I equals to what? Sine square x over 2 plus what? C. Sine x all squared is same as sine square x, then divided by 2 plus c. Now let's see the other method. The other method I will have used instead of this method. Then you can choose from the two methods, okay? You can choose the one you want. Look at this. Solution to this. We're going to say let u equals to what? Sine x. So I will differentiate this. We have du, dx equals to what? Cos x. So that means our du equals to sine x dot what? Dx. Right? We just cross multiply there. Du equals to sine x dx. Now we are asked to evaluate this, right? We have integral of sine x dot cos x dot dx, which is this, right? This is equals to, let's see, sine x is already u, right? We have u. Cos x dx, sorry, we made a mistake here. But we differentiated du dx, we have cos x. By the time we cross multiply, this should be du equals to what? Cos x dot what? Dx. I'm sorry for that. So originally we are given this, right? So let's see how we can evaluate this further. Sin x is already u, so we have u. Then dot cos x dx after differentiating is what? Du. So this was u du. And by the time we differentiate u with respect to what? Du, that will give us what? U to the power of 2 over 2 plus what? C. So our integral I becomes what? Our u is sine. So you have sine x all squared over 2, then plus what? Plus c. So integer I becomes sine square x over 2 plus what? Plus c. This is just how simple this other method is. They are all the same. Okay, they are all the same. So anyone that is convenient for you, you can go with. Let's see another example. Let's see another example. Please, if you are following, indicate in the comment section. Here we are asked to evaluate integral of ln x divided by x dot dx. Okay, ln x divided by x dot dx. Solution to this. Solution to this. Okay, sorry. Solution to this. This expression here can also be expressed as ln x over x dot dx can also be expressed as integral of 1 over x dot ln x dot what? Dx. Of course, yes. Ln x times 1 is ln x over x, then dot what? Dx. I just have to expand this so we can see the two products, because our aim is to convert the whole of this to be in what form? In the form of integral of what? F u dot what? Du, right? U dot du. So looking at this, I can make my u 1 over x. And by the time we differentiate 1 over x, that will give us, okay, I'll make my u ln x, right? When you make your u ln x, u is ln x, then du dx will give us 1 over x. Is that not? Of course, yes. We make our u ln x, then when you differentiate u with respect to x, we have 1 over x in the table of differentiation. So let's go. So let's determine our u. We are going to say let u equals to ln x. So I will differentiate this. It means du dx will give us 1 over what? X. When we differentiate ln x, the result is what? 1 over x in the table of differentiation. So that means by the time we cross multiply this, our du becomes what? 1 over x dot what? Dx. Is that not? I cross multiply this, we have 1 over x times dx. 1 over x dx is already du. Ln u is already what? U. I'm done with this. I'm done. When you make your u to be ln x, differentiate u with respect to x, we have 1 over x. Cross multiply, that will give us the u equals to 1 over x dot what? Dx. Right? Then let's find out if this expression occurs here. Of course, it occurs here. 1 over x dx can be captured here, right? So that means 1 over x dx is my u. If I'm to bring out 1 over x dx as my 1 over x ds as my u, as my du, that means the remaining expression is what? Ln x. And what's that? Ln x is u. Okay. All right. So let's move on. So here we have integral of 1 over x ln x dot dx. This can also be expressed as integral of ln x dot 1 over x dx. Of course, what I just did there was to bring out ln x first. Then here we have 1 over x dx. And 1 over x dx is du, right? So that means our I becomes integral of ln x. Ln x is u. So here we have u dot 1 over x dx is du. So u du. So when you integrate u with respect to the u, that will give us what? U squared over what? 2, then plus what? C. So our integral I becomes what? The value of u is ln x. So we have ln x all what? Squared, all divided by 2 plus what? C. This is the final answer here. Please, if you are following, indicate in the comment section. Next question. Please indicate in the comment section. All right. So let's continue. Let's continue. I hope you are following. Next question. Next question says that we should integrate tan x dot sec square x dot dx. So what do we do here? We already know that when we differentiate tan x, we have sec x. So it's better we use u to replace what? Tan x. I have to say let u equals to tan x, because when you differentiate u with respect to x, I will have sec square x, right? The derivative of tan x is equal to sec what? Square x. Okay, so I will say let u equals to what? Tan x. So that means my du dx will give us what? Sec square x. By the time we cross multiply, that will give us our du equals to what? Sec square x dot what? Dx. Du equals to sec square x dx. Okay, this is equation 1. This is what? Equation what? 2. So that means integral of tan x dot sec square x dx will be, look at this. Already we said our u is what? Tan x, right? Sec square x dx is du. After differentiating, we cross multiplied. So sec square x dx is already du. So what do we do here? I will just replace direct. My tan x is u dot sec square x dx is what? Is du. Is that not? Is du. So I can further integrate this. Therefore, my I equals to u to the power of 2 divided by 2, then plus c. Okay, so our integral becomes, our u is tan x. So I have tan x all squared over 2 plus c. So integral I becomes tan square x over 2, then plus what? C. Final answer. Tan square x over 2 plus c. Okay. Next question. We are asked to evaluate integral of 8 cos 4x dx. Please, I will pause this video. You have 2 minutes to solve this video, Just 2 minutes. Just 2 minutes, okay? Then tell me the answer in the comment section. All right, so let's continue. Anyone in the comment section, have you been able to solve it in the comment section? Anyone? Okay, nobody. So let's just solve together. Let's solve together. So what we do here is to let u, say let u equals to 4x. If v equals to 4x, okay, I will differentiate you with respect to what? X. That will give us du over dx equals to 4. So here I will cross multiply to find du. Du becomes, we have 4 dx, right? 4 dx. Okay, 4 dx. That's our du. Okay, so let's see what we're going to do here. I can make my dx as subject of the formula, right? In this case here, can make my if you look at this here, I don't have a direct expression that can give me 4 dx here. This is 8 dx. At the moment I have 4 here. If here is 4, I will have just replaced my du. That will be u cos what? Cos u, right? Du cos u. But in this case here, after differentiating, we have 4 ds. So 4 is not here. I need somebody. So what we do is to make my ds as well. Sorry, on formula to stand alone as subject. I will make ds as subject, and that will give us. It means I will divide both sides by 4 by 4. So that means here I'm going to have dx to be equals to du over 4. Du over 4. So after dividing, when you divide this by 4, our dx becomes du over 4. Therefore, our integral I becomes integral of 8 cos 4x dot dx equals to I equals to integral of 8 cos 4s is u dot our dx. This is the s, right? This is the x. The x is the u over 4. The s is the u over 4. So this becomes I equals to 8 over 4. 8 over 4 integral of cos u dot what? Du. The right to integrate cos u is du, so we can integrate du. Don't forget that we say that when you differentiate sine u, we have cos u. When you integrate cos u, the reverse is what? Sine u, right? So that means integrating cos u with respect to u, du, I will have what here? Sine u. So my integral becomes 8 over 4 is 2. Is 2, all right? Okay. We're going to have 2 integral of, okay, so okay, 2 times rather, integrating cos u, we have sine u plus what? Plus c. And that will give us I equals to 2 sine, our u is 4x. 2 sine 4x plus what? C. Final answer. 2 sine 4x plus c. Next question. Next question. How many of you solve this in the comment section? Please indicate. If you solve, indicate in the comment section. Next question. Says integrate, evaluate integral of s cubed. Integral of s cubed. X to the power of x. Sorry, integral of s cubed exponential x to the power of 4 dot dx. We are asked to integrate this. From the comment section, if you can integrate this, indicate. If you can integrate this, please indicate in the comment section. If you can integrate. And what do you think will be our u here? Now let's look at this together. I can't make this my u. If I'm to make this my u, if u equals to s cubed, that will give us the u equals to what? 3x squared, right? Dx. There is no way 3x squared can cancel what? This expression here. But I can make x, my u rather, as x to the power of 4. I can say let u equals to what? X to the power of 4. By the time I differentiate u, that will give us what? 4x cubed dx. Is that not? 4x cubed what? Dx. And by the time we make our dx as subject, that will also give us du over what? 4x cubed. From here, x cubed, we now cancel this x cubed here. Are you there, somebody? You know, why we are integrating this is that we'll be conscious of the value of x. We'll look for every possible means to eliminate this x. Are we there, somebody? Because if we are saying that let this equals to u, it simply means that I can't have s variable here. Are you there, somebody? Okay, but there are other integration forms. We'll be talking about integration by parts and all that. But for this expression, this is not integration by parts. Are we there? So just look at what I'm saying. Is that I'm going to say let u equals to x to the power of 4. Then here we have our du over dx to be equals to 4x to the power of 3. Right? Okay. So here, by the time we cross multiply, our du equals to what? 4x to the power of 3 dots dx. By the time we make the x a subject, we have the x equals to du over 4x to the power of 3. Let's call this equation 1. Equation what? 2. Equation 2. But recall that I is given as integral of this, right? X to the power of 3 exponential x to the power of 4 dot what? Dx. Which is also equals to integral of x to the power of 3 exponential, our x to the power of 4 is u, exponential u dot our dx is du over 4x cubed, is du over what? 4x cubed. So yeah, s cubed can cancel what now? S cubed. Are you saying the reason why we have to make this as a u? So that means our I becomes integral of the e to the power of u dot du over what? 4, which is also equals to 1 over 4. I will factor out the fraction here. 1 over 4 integral of eu dot what? Du. So our integral becomes, we say that if we differentiate e to the eu exponential u, if we differentiate exponential u, we have exponential u. If we integrate the same thing, we have what? Exponential u. Okay? The value of exponential function does not change during differentiation and integration. So here we have 1 over 4. Integral of this remains eu plus what? Plus c. So our I becomes 1 over 4 e. Our u is x to the power of 4, then plus c. Final answer. Take note of this. Take note of that. So let's move on to the next. Let's move on to the next question. We are already rounding up with this part. I just want us to look at some more complex example. The next question here. Next question. Please, if you join this live class, click on the like button. Don't just join and be looking at us. Please join and click on the like button for more visibility. Please click on the like button. Please click on the like button. This question says evaluate integral of 8x 8x square root of 40 minus 2x squared dots the x. Integral of 8x times square root of 40 minus 2x squared dx. Solution to this, let's determine our u. I want to say let u equals to this, equals to 40 minus 2x squared. All right, so I'll differentiate the u, the x. When you differentiate a constant value, the result is already 0, right? So this is already off. Differentiate this using the power rule. 2 times minus 2 is what? Minus 4x, right? To the power of 1. Okay, so my du dx is this. So here we're going to have our du to be minus 4x minus 4x minus 4x dx. So let's make our ds a subject on the formula to stand alone. So making ds a subject, we have the x equals to du over minus 4x. So this is equation 1, this is equation 2, right? Okay, so let's see. Our integral of 8x dot root 40 minus 2x squared dx will be I equals to integral of 8x dot root u, right? The whole of this is u, so this becomes root u dot our dx. Our dx is du over minus 4x, is du over what? Minus what? 4x. So s can cancel s from here. So our integral becomes integral of 8 dot root u dot du over minus 4. So this is 8 over 1, right? So our integral becomes what here? Divide 8 by 4, we have minus 2. So I will have minus 2. Integral of, we are left with what here? Root u dot what? Du. Is that not? Of course, yes. So the next thing we have to do, is to evaluate this further. Okay, this can also be expressed as I equals to minus 2 integral of u to the power of half dot what? Du. I've already taught us how to integrate the power, using the power rule of integration. With the power of integration, the rule says that if I have x to the power of n, the result says what? X to the power of n plus 1 over what? N plus 1, then plus c. So I will apply the power rule of integration here. The power rule of integration. This becomes our I equals to minus 2 times u. I will add half. I will add 1 to half, right? That will give us half plus 1 over half plus 1, then plus c. So let's finish up this. I equals to minus 2. U, half plus 1 should be about 3 over 2. Don't forget, 3 over 2. Half plus 1, meaning half plus 1 over 1. The LCM here is 2. 2 into 2 is 1. 1 times 1 is 1 plus 2 into 1 is 2. 2 times 1 is 2. So this will give us 3 over 2. Is that clear? Okay, so let's finish up this. Okay, let me use this space here. Instead, let me use space. Please take note of all of this we are doing. Let me use space. So here, from here, from here we have our I equals minus 2 dot u half plus 1 over half plus 1, then plus c. So I becomes minus 2 u to the power of 3 over 2 divided by 3 over 2 plus c. All right? Divided by. Why do I say divided by? This is division, right? This is divided by. This is also, if this power is 3 over 2, this is also 3 over 2. So this is like saying divided by 3 over 2, then plus c. So our I becomes minus 2u to the power of 3 over 2 times 2 over what? 3. Then plus what? C. Don't forget. Plus c. So what will be the final answer? The final answer becomes our I equals to minus 2 times 2 will give us 4. Then divided by 3. So we have minus 4 over 3. U to the power of 3 over 2. Then plus c. Then our I becomes minus 4 over 3. Our u is 40 minus 2s squared. We have 40 minus 2s squared, all to the power of 3 over 2, then plus what? C. Final answer for this question. Final answer for this question. Okay. I hope you guys are following. Final answer. Now let's look at integration of another form. We are done with this form. If you have any question, you can always reach out to us in the comment section. For those of you that will need a private tutor, you can always reach out to us in the comment section. All right, so let's finish up this. The next form I want us to look at is integration of the form. Integration of the form. The form is integral of f prime of x over f of x. Or this is also integral of f du over u. Okay, integration of the form. We have different forms. We take them one after the other. Today, we just capture 2 forms. This is the second form we are capturing today. All right, integration of this form. We have seen the first form, which is integral of u dot what? Du. We have to make a function u, right? Then differentiate u to generate what? Du. The same concept here. I have to make my denominator what? U. Then differentiate that u to get what? Du. That's what this form is saying. Let's see a good example. A good example says that if we are given evaluate 2x plus 4 over s squared plus 4x minus 19 dot what? Dx. Whenever you're given a function like this to integrate, whenever you're given this, once you differentiate the denominator, and the result becomes what? The numerator. It means I will have to use this form. So here I will have to say let u equals to what? S squared plus 4s minus 19. Then by the time we differentiate this function here, it will give us this. And of course, it's true. Differentiate x squared, we have 2x. Differentiate 4s, we have 4. Differentiate, we have a 0. So that will give us 2s plus 4. Now let's apply and see what will be the result of this. I'm going to say let u equals to s squared plus what? 4x minus 19. So here our du, right? Our du dx will give us 2x plus what? 4. By the time we cross multiply, right? By the time we cross multiply, That will give us our du equals to 2s plus 4 all in what? Dx. I can also take it off from here, or I can also make my ds as what? As sort of formula to stand as subject of the formula. I can make my ds as subject of the formula, or I can also use this stage here to solve the entire equation. To solve. From here, look at this here. My du is 2s plus 4 dx. Already I have 2s plus 4 dx here. This is like saying dx over 1, abi? Dx is multiplying 2s plus 4. So, okay, ys squared plus 4s minus 19 is multiplying what? 1. So that implies that 2s plus 4 times dx, which is what? Du. And this follows this form, abi? We have du over what? U. So the whole of this here, 2s plus 4 and ds is our u. Why this is what? Sorry, 2s plus 4 times ds is our du. Why this is what? Our u. All right? So what do we do here is that we say integral of 2x plus 4 over what? S squared plus 4x minus 19 dot dx is equals to integral of 2s plus 4 ds is equals to du. So we have du over s squared plus 4s minus 19 is what? U. So this is over u. This is same as integral of 1 over u dot what? Du. Don't forget that integration of an inverse function of this kind will always give us ln. So integral of 1 over u will give us ln u plus c. So that means our final answer becomes what here? Becomes ln u plus what? Plus c. Ln u plus c. So our integral becomes ln. Our u is s squared plus 4x minus 19, then plus what? C. Plus c. Alternatively, let me show us some. Please take note of this. From here, like I said, I can also make my ds as well, solve on the formula to stand alone as the subject of the formula. Then I will substitute my ds into this expression here to solve further. Let's see what will be the result alternatively. So from here, let's make our ds as subject of the formula. So my ds here will be du, right? Over what? 2s plus 4. Is that clear? 2s plus 4. So by the time we put the value of my ds as du over 2s plus 4, that will give us our integral of 2s plus 4 over s squared plus 4x minus 19 dot dx will be integral of, we have 2x plus 4 over u, right? Over u times our dx is du over 2x plus 4 is du over 2x plus 4. This will go with this, right? So that means our integral remains integral of du over u, which is same as what? Integral of what? 1 over u dot what? Du. So by the time we integrate this, it becomes 1 over u will give us what? Ln u plus what? C. And that will give us I equals to what? Ln. Our u is s squared plus 4x, s squared plus 4s minus 19, then plus c. Final answer. Any one you want to use, you are still correct. Both steps will give you the same answer. All right, so let's look at another example under this form. Another example under this form. Okay, another example says, here we have integrate 4s cubed divided by s to the power of 4 plus 10 dot the x. So yeah, this is of this form. Look at this. When you differentiate this, we have this. So this is of this form. So I'm going to say let u equals to s to the power of 4 plus 10, right? So, and that will give us our du over dx equals to 4x to the power of 3. So yeah, our du becomes 4x to the power of 3 dot what? Dx. The whole of this here is equals to du, which means my 4x cubed times the x will be replaced with what? Du. Okay, so this is equation 1. This is what? Equation 2. Or we can also make our dx as well, solve it on the formula, then substitute the value of the x into this expression, right? To solve further. Any method you want to use, you are 100% correct. So let's go. Let's go. So here we have here as integral of 4x cubed dx over, this is same as this, over s squared plus 10 is equals to 4x cubed dot dx is du. This is equals to du divided by s squared plus 10 is u. And this will give us integral of 1 over u dot what? Du. So our value of integral becomes, integrating 1 over u will give us what? Ln u plus c. So I is equals to what? Ln, our u is s to the power of 4 plus 10, plus 10, 10 plus c. Final answer here. We are done with this. We are done with this. Or like I said, I can also make my ds a subject or the formula. Then by the time we place it here, 4s cubed, we cancel 4s cubed. Then we'll be left with du over what? U. Any method, you are 100% accurate. Next question. Next question. Next question. Let's look at this. We are asked to integrate 6x plus 7 divided by 3x squared plus 7x plus 1 dot dx. Okay, let's apply. We're going to say solution. Let u equals to 3x squared plus 7x plus 1. Right? Okay, so yeah, we're going to have here as our du over dx is equals to 3s squared, equals to 6s plus 7. 6s plus 7. So that means our du equals to 6s plus 7, all in what? The x. All in the x. So let's apply this other method. Let's make our ds a subject of the formula. So to find the x becomes what here? Our dx becomes du over what? 6s plus 7. This is the second method. Okay. Already, I can also use this direct, right? 6s plus 7 ds is 6s plus 7 ds. So this is my, from here to here, this time this is my du over what? U. I can solve. Or I can make my ds as well, subject of the formula, and still solve. This we cancel out what this. Let's see. Therefore, we have integral of 6s plus 7 over 3x squared plus 7x plus 1 dot dx is equals to integral of, let's fix our value. We have 6x plus 7 over u dot, our dx is du over 6x plus 7, du over 6x plus 7. So this can go with this. So we are left with our integral equals to integral of du over u, which is equals to integral of 1 over u dot du. So our integral becomes integral of an inverse linear function will give us ln u. We have ln u plus c. So I becomes what? Ln, our u is 3x squared plus 7x plus 1, then plus c. Let's see a more complicating example. A more complicating example. A more complex example. All right, so I'm going to take my time to explain this other example. A more complicating example. Okay. Yeah, we are asked to evaluate 6x squared divided by x cubed minus 8 dots dx. Look at this question. Solution to this is that I'm going to say let u equals to what? X cubed minus 8. Is that clear? Then I will differentiate this, the u, the what? The x equals to what? 3x squared. What you notice here, after differentiating this, the result is not equal to this. But that does not mean that the equation is wrong. Just keep on solving. In this case, I will make my ds as what? As the subject of the formula to stand alone as the subject. Let's make our ds as subject of the formula. So we have du over dx. Okay, so when we make our dx as subject, I will cross multiply first, right? So we have our du equals to what? 3x squared dot what? Dx. So that means my dx will be du over 3x squared. The most important thing is that by the time we put this du over dx into this expression, x squared will cancel what? X squared. And that will give us what we need. So let's finish up this. So this is my equation 1. Equation 2, right? So here we have integral of 6x squared over what? X cubed minus 8 dot dx equals to integral of, we have 6x squared over, here we have here as u over u dot, our dx is du over 3x squared, du over 3x squared. So here we have our integral becomes integral of, this can actually go, x squared cancel x squared, 6 divided by 3 will give us 2. So we have 2 divided by u dot what? Du, right? Of course, and this will give us 2, and we have to factor out this constant as 2, 1 over u dot what? Du. So our integral becomes, we have 2 ln integrating 1 over u will give us what? Ln u, then plus c. And this will give us our integral equals to 2 ln, our u is x cubed minus 8, then plus c. Final what? Final answer. 2 ln x cubed minus 8 plus c. Final answer. Okay. Final answer. Let's see one more example. One more example or two. We have a question that says, evaluate integral of the x over 13x plus 4. 13x plus 4. This is just a good example of a linear, inverse linear function. Of course, but let's see. This will give us integral of this same as 1 over 13x plus 4, right? Dot what? The x. So I'm going to say let u equals to 13x plus what? 4. So my du, the x is equals to what? 13. So I'm going to multiply here to make my ds a subject of the formula. That will give us our du equals to what? 13 dx. Exactly 13 dx. So here my dx becomes du over what? Over 13. Du over 13. So I'll put this and this in the equation. Right? Let's put the value. So we have our integral of 1 over 13. 1 over 13x plus 4. The x equals to integral of 1 over our 13x plus 4 is u dot the x is du over 13. So we have du over what? 13. Is that clear? Du over 13. So here becomes I equals to 1 over 13 integral of 1 over u dot what? Du. So here we have I equals to 1 over 13 ln u plus what? C. So our integral becomes 1 over 13 ln, our u is 13x plus 4. We have 13x plus 4, then plus C. Final what? Answer. Final answer. Okay. Next question. Please take note of this. Next question. We are asked to evaluate integral of sec square x divided by tan x, all in what? The x. Okay, let's look at this together. If you look at this, when you differentiate tan x, that will give us sec square x. That means it's of this form. So we can apply this form. We'll just say let u equals to tan x. So that means our du over the x will give us what? Sec square x. Is that clear? Sec square x. So by the time we cross multiply this, we're going to have the u equals to what? Sec square x dot what? The x. So let's make our dx a subject, or from here, you'll find out that sec square x dx is actually here, and it represents what? Du. So I can do a direct substitution. So that means our integral of sec square x dx over tan x is equals to sec square x dx is du. So we have integral of du. Our tan x is actually u, so over u. And that will give us integral of 1 over u dot what? Du. So here we have I equals to integral of 1 over u is ln u plus c. So our integral becomes ln, right? Ln, our u is tan. So we have ln, our u is tan x. So ln of tan x, then plus what? C. Final answer. Final answer. So I will do some class exercise, some assignment or class work for you guys. Please attempt all of this for me. In my next class, I will start with them. In my next class, I will start with those questions. In my next class, I'm going to start with them. Please evaluate the following. Evaluate the following. The following. Number 1, integral of 2x plus 4 over x squared plus 4x plus 1 minus 1 dot dx. Number 2, integral of cos 3x over sine 3x. Okay. Number 3. Number 3, evaluate integral of 5 exponential 5x dot what? Dx. Number 3. Number 4. Evaluate integral of exponential minus 10x minus 12. Number 5. Evaluate integral of x squared exponential 2x. So these are the assignments. These are the class exercise. Please ensure you attempt this, okay? Our next class will be tomorrow or next, either tomorrow by 8 p.m. or on Monday by 8 p.m. That same 8 p.m. Either we'll meet tomorrow, be Sunday by 8 p.m. or on Monday by 8 p.m. I want to make sure we exhaust everything about integration. There are other forms of integration. In my next class, we'll look at other forms like integration by partial fraction, integration by parts, and integration of logarithm function, exponential functions, and the rest, and so many other forms of integration. So please take note of this. These are your assignments. Attempt them. Drop the answer in the comment section. Ensure you attempt, okay? Ensure you attempt. Your response to this assignment will determine if I will come online again to teach or not. So please ensure you attempt, or if you need a direct tutorial, you can always contact us with this number 09063 111 961. You can also drop your assignments on my WhatsApp with this number. This is my WhatsApp number. You can drop your assignments with this on this WhatsApp number. All right. Any information you need, you can always chat me up. If you need more clarification, you can chat me up with this number. So thank you guys for joining us tonight. We meet tomorrow or on Monday by 8 p.m. Thank you. All right, guys. So we see you tomorrow. Welcome, guys. Please make sure you click on the like button. Click on the like button before you leave.